Let's do two examples with the squeeze theorem. First of all, I'm going to give you a little hint. And the first one's in your notes, the second one's not, but I suggest you add it to your notes. So here's my big hint, and you probably should put this in your notes too. My hint is, if you have a function multiplied by sine blop or a cosine blop, think sandwich, squeeze theorem, because let's think about sine and cosine. So the reason that we can use the sandwich and squeeze theorem sometimes with sine and cosine is because sine blop and cosine blop, no matter what the blop is, oscillates between -1 and 1. All right, so if you've got a function times 1, well, that's the same function. If you've got a function times -1, well, that's the opposite of that function. And if you've got a function being multiplied by anything between -1 and 1, it's going to be either A, if it's between 0 and 1, it's going to be smaller than the original value. If it's between 0 and -1, it's going to be smaller in absolute value, and the opposite. All right, so anything that's multiplied by sine blop or cosine blop is never greater than or less than itself or the opposite of itself. All right, so to be alphabetical, let's put the original function in the middle there. All right, so the limit as x approaches 0, x cubed cosine blop. There we go. By the way, it doesn't matter who's f of x, who's g of x, and who's h of x. If you want h of x to be between f of x and g of x, there's no reason it can't be. All right? So long as your explanation is correct and everything is labeled correctly. Right? But we'll just put it in the middle. All right, so now let's think about, let's make f of x the least our function can be. And the least is going to occur when cosine blop equals -1. So if cosine blop equals, let's make that a little, I hate having the equal sign hanging out all by its little lonesome. If cosine blop equals -1, then our function there, and it'll be f of x, then f of x would equal -1 times x cubed. So that's going to be the smallest the function can ever be, and that occurs when cosine blop equals -1. It will never be less than whatever -x cubed is. All right, let's look at the other, on the flip side. If cosine blop equals 1, then h of x equals 1 times x cubed. The most our function can ever be is whatever x cubed is. Right? And the limit that we're looking for is sandwiched in between those two, thanks to the fact that cosine blop is oscillating between -1 and 1. All right, so now let's find the limit. I don't want to use the same. I don't want to use the same color as the blue over there, otherwise I'm going to blend in. All right, so let's find the limit of f of x. All right, well that would just when x approaches 0. That's just the limit as x approaches 0 of -x cubed, and we can plug in there, no problem with that polynomial. All right, that would be -0 cubed, that is 0. The limit Let's find the other limit. The limit as x approaches 0 of h of x. That would be the limit as x approaches 0 of x cubed. Again, we can plug in 0 cubed. Well, that's 0. Well, now you've got a function. I love bells. And it rings a very long time. So now you've got a function who's sandwiched between two functions and whose limit and those two functions have the exact same value for their limit as x approaches 0. Well, that means you now know the limit of the function you're looking for using the sandwich rule. And all we need to do now is justify it. We've got our explanation, we've got the functions, we've got our work. Right? All we need to do is justify. So since f of x is less than or equal to g of x, it can be equal to, right? That's an important fact. It's going to be equal, right, if g of x equals negative 1. If the cosine equals negative 1, then g of x equals f of x, which is less than or equal to h of x. It's going to be equal when the cosine blop equals 1. So since that is true, and the limit as x approaches 0 of f of x equals the limit as x approaches 0 of h of x, then, and don't forget to reference this. Right? It doesn't matter whether you call it sandwich or squeeze theorem, but make sure you reference it. So according to sandwich theorem, the limit as x approaches 0 of g of x, which we have labeled, right? So we did label our function as g of x, so we are okay in just calling it g of x. If you're worried about it, you can give its name too, right? But since we've labeled it as g of x, we are okay to call it g of x, right? So the limit as x approaches 0 of g of x equals 0, 2, right? So when you're justifying, make sure you note the important pieces of information that are the limit that we're looking for is between two functions which we can find the limit of. How do we know? Well, that's this right up here, right? The fact that cosine can only be at most 1 or at least negative 1. All right, so we've justified why our function that we're looking for the limit for is sandwiched in between two other functions. We have found the limit, that's right over here, and found those two limits of these two functions that our function that we're interested in is sandwiched in between, right? And they are the same, right? So since those two limits are the same, then according to sandwich theorem, because the function we're interested, the function of interest, the limit of interest, is in between the other two functions, and those functions have the same limit, well then the limit of g of x has to be 0 as well. All right? This is all you need to perfectly justify. And you can call it squeeze or sandwich. Right? That part doesn't matter. Let's do one more. This time it will be with sine. It's a brand new problem, not in your notes. I suggest you add it. All right? Find a spot to add it. All right? It takes up as much room as the other one did. You know, you could even put it on the back of one of those pages. Like, for instance, the next, I don't know, I don't have it in front of me, but there's all those chapter things. You could just put it there. Right? All right, so let's find this one. We've got sine blop, right? And we know sine blop oscillates. So I'll just write that up here. So at most, or at least, let's go at least first. At least, sine blop is negative 1. At most, sine blop is 1. We know it has to be sandwiched in between there, which means we can use the sandwich rule, the sandwich theorem. All right, so let's identify our functions. F of x, g of x, and h of x. Let me just make sure I have enough space here. I hate it when my work is crammed. let's just call, just to be alphabetical, the one in the middle, right? The one that's stuck in the middle, let's call him g of x. So the limit as x approaches 1, actually don't even really need to write this limit part, just the name of the function. X minus 1 sine pi x minus 1, right? Really all I need is the function. I don't know if I wrote the limit on the other page. Let's see. Yeah, but I did it for the middle one. That's what you get when you're copying. The limit part wasn't needed. Just the function. All right, and then let's see, what is it in between? All right, so now, this time I decided to go f of x and let's just make it look the same. By the way, the order you write things in doesn't matter, but for consistency's sake, we'll put the larger one on top so it matches the other one. All right. If sine blop equals -1, then f of x, so in other words, this whole part here is -1. What are we left with? We're left with -1 times x minus 1, right? Which equals -x plus 1. I'll just leave that up there. Right, so that means that f of x is going to be -x plus 1. Right, so our function, x minus 1 times sine blop, is never going to be less than -x plus 1. And that will occur, it'll be equal to it when sine blop actually is -1. If sine blop is 1, then h of x, I should have if I have an if, I really should put a then in, huh? An implied then? Then h of x equals 1 times x minus 1, which is just x minus 1. All right, so the most that x minus 1 sine blop can be is x minus 1. Right? The least it can be is -x plus 1. Right? It is sandwiched in between thanks to the fact that if you multiply by something that is between -1 and 1, right, you are going to have something smaller in absolute value. All right, so now let's take the two limits. I'll write green this time. All right, so I'll put that over here, I guess. So the limit as x approaches 1 of f of x, which is the limit as x approaches 1 of -x plus 1, we can plug in. That's just going to be -1 plus 1, which is 0. Right, if you plug, because the negative's already there. Right, and now let's find the other limit. So the limit as x approaches 1 of h of x equals the limit as x approaches 1 of x minus 1, which is 1 minus 1, which is also 0. All right, so we've met the two requirements. The fact that our function's got to be sandwiched in between those two functions, and those two functions have the same limit as x equals 1. So now we can find the limit of g of x as well. So since f of x is less than or equal to g of x, right, it'll be equal when sine blop is -1, is less than or equal to h of x, it'll be equal when sine blop is 1, and the limit as x approaches 1 f of x equals the limit as x approaches 1 of h of x. And by the way, see, we have the limit right here, right? So that's why it's okay for me not to have to write the limit in on my explanation, because we have it right up there. then according to the sandwich theorem, the limit as x approaches 1 of g of x must also equal 0. And there we go. I use a slightly different words, but it is saying the exact same thing. Right? We have found our limit here using the sandwich rule because our function meets the requirements. It's sandwiched in between two functions who have the same limit at some point. All right? So, if you like, I can do more. I've got more problems from the book, but I'm hoping that seeing one sine and one cosine and the fact that these look a little different will help you out, but I certainly can do more. But thanks for watching this video. Bye for now.